Imagine an object against the background of which our entire solar system looks like a barely noticeable grain of sand in an endless desert. This is TON 618, an ultra-massive black hole that tears the very fabric of space and time. It is the heart of the brightest quasar, yet inside it reigns absolute, eternal darkness, from which not even light is able to escape. Today, we are embarking on a journey to the farthest reaches of the knowable, to understand how the existence of this titan challenges the laws of physics. Are you ready to look into the abyss that has been looking at us through billions of years? The history of the discovery of TON 618 is not just a chronicle of a single observation. It is the story of how humanity step by step realized that the universe is much more aggressive, massive, and strange than we could have imagined even 100 years ago. To understand the nature of this titan, we must return to the times when the very concept of a black hole was considered only a mathematical exoticism, and no one even guessed the existence of objects capable of overshadowing entire galaxies. Right where you are watching from, it is interesting to see how far our stories diverge. We are beginning. For millennia, the sky seemed static and eternal to us. However, the middle of the 20th century changed everything. The emergence of radio astronomy allowed scientists to see the universe in ranges invisible to the human eye. In the 1930s, Carl Jansky, working in the Bell Company laboratories, recorded strange radio interference coming from the center of our Milky Way galaxy. This became the first hint that space is full of invisible sources of colossal energy. However, the real mystery arose later, in the 1960s. Astronomers began to record objects that in optical telescopes looked like ordinary, although somewhat blue, faint stars. But when researchers analyzed their radio signals, they encountered an anomaly. These objects emitted such an amount of energy that would be impossible for any single star. They were called quasi-stellar radio sources, or quasars. A key breakthrough occurred in 1963 when the Dutch-American astronomer Martin Schmidt investigated the object 3C273. He noticed that the lines in the emission spectrum of this star were strongly shifted to the red side. According to Hubble law, this meant that the object is not located in our galaxy, but at a distance of billions of light-years from Earth. It was a shocking discovery. To be visible at such a distance, the object had to be hundreds of times brighter than all the stars of the Milky Way combined, concentrated in a space no larger than our solar system. It is in this atmosphere of scientific search that TON 618 appeared. It was first noticed in 1970 during a large-scale sky survey at the Tonantzintla Observatory, which is located in Mexico. Scientists Braulio Iriarte and Enrique Chavira were searching for blue stars in high galactic latitudes, away from the disk of our galaxy. In their catalog, this object was recorded under the number 618. At that time, no one could have assumed that behind this modest number hides the most massive black hole known to science. For a long time, TON 618 remained just another line in a catalog of faint objects. However, further studies, in particular using new generation spectrographs, revealed its true nature. When astronomers measured its redshift, which was 2.219, it became clear. We are looking at light that was emitted 10,800,000,000 years ago. This means that TON 618 already existed when the universe was very young. It was only about 3 billion years old. The true scale of the tragedy and grandeur of this object was revealed thanks to a detailed analysis of the emission lines in its spectrum. Scientists paid attention to the incredible width of the hydrogen and magnesium lines. In physics, this phenomenon is explained by the Doppler effect. The gas around the central object moves at frantic speeds, thousands of kilometers per second. To keep such heated gas in orbit and prevent it from flying apart in different directions, there must be something with colossal gravity in the center. When scientists substituted the obtained data into the equations of gravitational dynamics, the result forced them to check the calculations several more times. The mass of the central object was 66 billion masses of our Sun. This number is hard to comprehend. If our Sun is 1 grain of sand, then ton 618 is an entire mountain of sand several kilometers high. No star cluster could have such a mass in such a limited volume. There was only one answer: an ultra-massive black hole. Why is this discovery so important for modern science? First, it questions our models of galaxy evolution. Official reports from the National Aeronautics and Space Administration and the European Space Agency often emphasize that the formation of such giants in the early universe is one of the greatest mysteries of modern astrophysics. According to standard theories, black holes need time to grow to such sizes by absorbing gas or colliding with other black holes. But ton 618 appeared too early. It is like meeting an adult person where, according to time, there should only be infants. Today, ton 618 is not just an astronomical object. It is a laboratory of extreme physics. Studies published in the journal Nature indicate that such quasars played a key role in forming the structure of the entire universe. With their powerful radiation, they stopped the formation of new stars in their galaxies, acting as a kind of regulators of cosmic growth. We look at ton 618 and see the darkest place surrounded by the brightest glow. This is the boundary beyond which our understanding of ordinary matter ends and the reign of the singularity begins. And to understand what is happening inside, we must disassemble the very physics of this monster, step by step plunging into the mechanisms that allow it to exist. When we talk about ton 618, we go beyond the usual understanding of astronomy and enter the field of extreme physics. This object is not just large, it is officially classified as an ultramassive black hole. To understand what this means, we need to disassemble the mechanisms that allow scientists to measure objects at a distance of 10 billion light-years and realize the physical parameters that seem impossible. How to weigh the invisible? The method of reverberation mapping. The first question that arises for any skeptic: how can we claim that the mass of the object is exactly 66 billion solar masses if we cannot even see the black hole itself? Since black holes do not emit light, astrophysicists use indirect but extremely accurate methods based on Kepler laws and Albert Einstein general theory of relativity. The main tool for measuring ton 618 is the so-called reverberation mapping. Imagine that you throw a stone into a deep, dark cave and wait for an echo. By the time it takes for the sound to return to you, you can determine the dimensions of the cave. In space, the role of the stone is played by flashes of radiation from the accretion disk, and the role of the echo is the reaction of the surrounding clouds of gas. Around ton 618 is a huge area that scientists call the broad line region. Here, the gas moves at incredible speeds under the influence of the black hole gravity. When the brightness of the central source, the quasar itself, changes, this pulse of light passes through the clouds of gas, forcing them to glow brighter after a certain time. By measuring the delay between the flash in the center and the response of the gas clouds, astronomers calculate the distance from the black hole to these clouds. Knowing the distance and the speed of the gas movement, which we determine by the width of the spectral lines thanks to the Doppler effect, we can accurately calculate the mass of the central body. For ton 618, the width of the hydrogen beta line in the spectrum turned out to be so large that the calculations led to a stunning figure: 66 billion masses of the Sun. For comparison, the black hole in the center of our galaxy, Sagittarius A star, has a mass of only about 4 million solar masses. This means that ton 618 is 15,000 times more massive than it. The event horizon and the Schwarzschild radius. The scales of emptiness. Any mass compressed to a critical volume becomes a black hole. This critical size is called the Schwarzschild radius. If we compress the Earth to the size of a walnut, it will become a black hole. But in the case of TON 618, we are dealing with an object whose dimensions are hard to imagine even on a cosmic scale. The calculated Schwarzschild radius for TON 618 is approximately 190 billion kilometers. This corresponds to a diameter of 380 billion kilometers. To understand this figure, remember the distance from the Sun to Neptune, the most distant planet of our system. It is only about 4.5 billion kilometers. That is, the radius of the event horizon of this black hole is 40 times greater than the distance from the Sun to Neptune. If TON 618 were in the place of our Sun, its dark mouth would swallow not only all the planets, but also the Kuiper belt, the Oort cloud, and would continue to stretch for light weeks deep into interstellar space. Light, which travels at a speed of 300,000 kilometers per second, would need more than a week just to cross this object from one edge of the event horizon to the other. Density and the paradox of large black holes. Here we encounter one of the most interesting paradoxes of the general theory of relativity. The more massive a black hole is, the lower its average density within the event horizon. In the case of TON 618, if we divide its mass by the volume bounded by the Schwarzschild radius, we get a value that is significantly less than the density of water. It would be even less dense than the air we breathe. This does not mean that it is empty inside the black hole in the usual sense. This means that the very structure of space-time is so distorted that a huge volume is filled with mass that inevitably heads to the center, to the singularity. However, for a hypothetical observer crossing the event horizon of such a giant, tidal forces would be minimal. Unlike small black holes, where you would be torn into atoms even before entering, a process known as spaghettification. In TON 618, you could cross the boundary of the unknown without even noticing it physically, at least at the beginning. The Eddington limit. Why TON 618 cannot grow forever. Another critical scientific aspect is the Eddington limit. This is the balance between the force of gravity, which pulls matter inward, and the radiation pressure, which pushes it outward. The quasar TON 618 shines so brightly exactly because it absorbs a huge amount of gas. This gas, heating up in the accretion disk, creates a colossal light pressure. If a black hole absorbs too much matter, the radiation pressure becomes stronger than gravity and literally blows away the surrounding gas, stopping the feeding of the monster. Official studies published in astrophysical journals indicate that TON 618 is very close to this theoretical limit. This means that we see the object in a state of maximum possible energy consumption. This is a cosmic engine running at maximum speeds. The study of spectral data obtained using the observatory of the Smithsonian Institution and European telescopes confirms TON 618 is not just a statistical deviation. It is the endpoint of the evolution of supermassive objects. It represents the theoretical limit of how large a black hole can become in our universe. When we look at TON 618, we see not just an object, but a majestic paradox that forces the world leading astrophysicists to reconsider the fundamental foundations of cosmology. The main question that remains open in the offices of the National Aeronautics and Space Administration and in the laboratories of the European Space Agency sounds simple, but at the same time is extremely complex. How did this titan manage to grow to such incredible sizes in just 3 billion years after the Big Bang? The problem of too fast growth. According to the classical model, stellar mass black holes are born after the death of massive stars. Then they gradually increase, absorbing surrounding gas or merging with other black holes. However, this process has its physical limitations. As we have already mentioned, the Eddington limit sets the speed at which a black hole can eat without pushing away its own food with powerful radiation. If TON 618 started its journey as an ordinary black hole with a mass of 10 or 100 solar masses, it would need much more time than the age of the universe itself to reach 66 billion solar masses. This means that either our ideas about the speed of accretion are wrong, or this object was born already gigantic. The direct collapse theory. Birth from chaos. One of the most discussed alternative theories is the hypothesis of direct collapse black holes. According to studies, the results of which are often published in the journal Nature, special conditions existed in the early universe. Huge clouds of primordial gas, mostly hydrogen and helium, could collapse under their own gravity, bypassing the stage of forming individual stars. In such a scenario, instead of a small seed, we get an object with a mass of 10,000 or even 100,000 solar masses from the very beginning. This gives Ton 618 a huge head start in the cosmic race for mass. For such a collapse to occur, the gas cloud had to remain very hot so as not to fragment into small clumps that would become stars. Scientists assume that powerful ultraviolet radiation from neighboring first galaxies could play the role of such a heater, preventing the cloud from cooling. Primordial black holes. The legacy of the Big Bang. Another intriguing theory that brings us back to the ideas of Stephen Hawking is the existence of primordial black holes. These objects could have arisen not as a result of the death of stars, but directly in the first moments after the Big Bang due to the extreme density of matter in certain points of space. If primordial black holes really exist, they could act as condensation centers around which matter gathered for the future Ton 618. This would explain why ultramassive black holes are located in the very heart of the oldest quasars. They did not just grow in galaxies, they helped these galaxies to form. The hypothesis of stupendously large black holes. In recent years, the scientific community has been actively discussing the possibility of the existence of even larger objects than Ton 618. Professor Bernard Carr and his colleagues proposed the term stupendously large black holes. These hypothetical monsters can have a mass of hundreds of billions or even trillions of solar masses. Although Ton 618 is currently the official record holder, some scientists assume that we simply have not yet discovered larger objects due to the limitations of our telescopes. Perhaps Ton 618 is just the tip of the iceberg in an ocean of dark matter and invisible giants that control the evolution of cosmic structure. Future missions. New eyes of humanity. To unravel these mysteries, humanity needs new tools that are able to look into the so-called dark ages of the universe. The first on the list is the James Webb Space Telescope. Thanks to its ability to see in the infrared range, it can break through the veil of cosmic dust and see the light of the first quasars, similar to Ton 618, at the moment of their birth. The data we are receiving from this telescope already makes scientists wonder how massive galaxies were at the very beginning of time. Another ambitious project is the Laser Interferometer Space Antenna, a space laser interferometer being developed by the European Space Agency with the support of the National Aeronautics and Space Administration. Unlike earthly detectors, such as the Laser Interferometer Gravitational Wave Observatory, the Laser Interferometer Space Antenna will be able to record low-frequency gravitational waves. It is exactly such waves that arise during the merger of ultramassive black holes. By hearing the trembling of space-time from such collisions, we will be able to learn the history of the growth of Ton 618 through direct observations of its past mergers. It is also worth mentioning the future Athena mission, an advanced X-ray telescope that will explore hot gas in the largest structures of the universe. It will allow us to see how powerful jets and radiation from Ton 618 affect the surrounding intergalactic space, practically shaping the landscape of the cosmos for millions of light years around. We are on the threshold of a new era of discoveries. Ton 618 is not just a static object in a textbook. It is a dynamic challenge to our imagination. Every new theory, every future mission brings us closer to understanding how such orderly, albeit terrifying, lords of darkness emerged from the initial chaos. We are used to thinking of black holes as cosmic vacuum cleaners that only absorb light and matter. However, Ton 618 shows us a majestic paradox. Being the darkest object at its core, it is at the same time the source of the most powerful glow in the known universe. How is this possible? The answer lies in a structure that astrophysicists call an accretion disk. This is a colossal engine that turns ordinary matter into pure energy, with an efficiency that is inaccessible to any other process in nature. The mechanics of friction and mass conversion. Imagine a huge whirlpool of gas and cosmic dust revolving around a central darkness. The matter that falls into the gravitational trap of ton 618 does not fall inside instantly. Due to the law of conservation of angular momentum, it begins to rotate, forming a flat disk. The closer the gas gets to the event horizon, the faster it moves. At the inner edges of the disk of ton 618, the rotation speed reaches a significant fraction of the speed of light, hundreds of thousands of kilometers per second. In this frantic dance, gas particles collide with each other with incredible force. Colossal friction arises. This is not just heating that we can observe on Earth. This is a process that heats the plasma to millions and even billions of degrees Celsius. It is here that Albert Einstein's famous formula about the equivalence of mass and energy comes into play. For comparison, thermonuclear fusion, which occurs in the depths of our Sun, turns only about 0.7% of the mass of hydrogen into energy. An accretion disk around an ultramassive black hole, such as ton 618, can turn up to 40% of the mass of the falling matter into radiation. This makes the accretion disk the most efficient energy converter in the universe. Ton 618 literally burns entire star systems, turning them into light, brightness that overshadows galaxies. According to official observation data, the luminosity of the quasar ton 618 is approximately 143 trillion luminosities of our Sun. This number is difficult for the human mind to comprehend. If you combine the light of all the stars in our Milky Way galaxy, and there are from 100 billion to 400 billion of them according to various estimates, then ton 618 will be brighter than thousands of such galaxies combined. This light is so powerful that it creates real physical pressure, radiation pressure. The photons flying out of the red-hot disk push the surrounding gas outward. As we already mentioned in the context of the Eddington limit, this pressure balances the terrible gravity of the black hole. Ton 618 is a cosmic cannibal that constantly tries to eat more than its own photons allow it to. The innermost stable circular orbit and the edge of the abyss. The critical point of the accretion disk is the so-called innermost stable circular orbit. This is the last frontier where matter can still revolve around the black hole without falling inside irrevocably. For ton 618, this orbit is located far beyond what we call a planetary system. When gas crosses this invisible line, it begins to fall rapidly toward the event horizon. At this moment, the last portion of energy is released: hard X-ray and gamma radiation. It is exactly these signals that our orbital observatories, such as Chandra from the National Aeronautics and Space Administration, record. By analyzing these high-energy bursts, scientists can see the processes occurring literally on the threshold of eternal darkness: magnetic fields and relativistic jets. But ton 618 not only absorbs, some of the matter approaching the event horizon never gets inside. Powerful magnetic fields generated by the rotation of the accretion disk capture the ionized gas and direct it along the axis of rotation of the black hole. This process creates two colossal relativistic jets. These streams of plasma burst from the vicinity of ton 618 at almost the speed of light, cutting through space for millions of light years. They carry energy far beyond the host galaxy, affecting the structure of intergalactic gas and preventing the cooling of matter, which in turn stops the birth of new stars in a huge volume of space. Thus, ton 618 is not just a passive observer. It is an active architect of the universe. Its accretion disk is the heart of an incredible machine that controls the fates of entire star clusters. We look at ton 618 and see the darkest place. But thanks to this red-hot disk, it becomes a beacon for us, allowing us to study the deepest mysteries of physics and gravity. The existence of TON 618 is one of the most powerful challenges for modern cosmology. When astrophysicists first confirmed its mass of 66 billion solar masses, it caused not only delight, but also some scientific concern. According to our current models of universe formation, such an object simply should not have had time to grow. This creates the so-called seed problem, which today is the center of heated discussions in scientific journals, such as the Astrophysical Journal and monthly notices of the Royal Astronomical Society. The paradox of time and the limit of growth. The Standard Model assumes that the first black holes appeared after the death of the first generation of stars, the so-called population 3 stars. These stars were huge, but even they could leave behind black holes with a mass of only a few hundred solar masses. To turn from such a small seed into a monster the size of TON 618 in 3 billion years, a black hole would have to absorb matter continuously at the maximum speed dictated by the Eddington limit. However, in the real universe, conditions are rarely so ideal. Galaxies collide, gas runs out, and the black hole's own radiation repels food. This forces scientists to look for alternative explanations. One of the most provocative theories is the hypothesis of super-Eddington accretion. Some researchers assume that in the special conditions of the early universe, black holes could overeat, absorbing gas much faster than our current formulas allow. If this is true, then TON 618 is evidence of an era of cosmic chaos where the laws of thermodynamics worked differently. Direct collapse and forbidden masses. Most theorists incline to the fact that TON 618 was born not from the death of a star, but as a result of the direct collapse of giant clouds of gas. This allows skipping the small seed stage and immediately obtaining an object with a mass of 100,000 or even a million solar masses. However, even this theory has its weak points. For such a cloud to collapse directly into a black hole, it must remain free of heavy elements, metals, and be subjected to intense irradiation from neighboring galaxies. This is an extremely rare combination of conditions. This makes TON 618 not just a large object, but a real cosmic lottery ticket, the result of a coincidence that happens once in a billion galaxies. Do stupendously large black holes exist? Another topic for debate is whether TON 618 is the absolute limit. Some scientists, relying on data about the large-scale structure of the universe, put forward a theory about the existence of stupendously large black holes, objects with a mass of more than 100 billion solar masses. The main argument against their existence is that at a certain stage the accretion disk becomes so large and massive that it begins to fragment under its own gravity, forming new stars instead of feeding the black hole. TON 618 is dangerously close to this theoretical limit of the disk's self-gravity. If we find something even larger, we will have to admit that we are fundamentally wrong in understanding how gravity interacts with matter on such scales. The invisible influence of dark matter. The role of dark matter cannot be ignored either. There are assumptions that TON 618 could have grown faster due to the direct absorption of dark matter particles, or it formed in the center of an extremely dense dark matter halo, which acted as a gravitational funnel, collecting gas from vast distances. Official reports of missions such as Planck from the European Space Agency provide data on the distribution of dark matter that indirectly support the idea that the early universe was a much more crowded and aggressive place than we see now. What do we still not know? Despite all our tools, TON 618 remains a point on the map where science meets the unknown. We do not know whether this black hole rotates around its axis, its spin. If its rotation is maximal, it would explain its incredible brightness, but it would make its origin even more difficult to explain. We also do not know the composition of its diet, whether it absorbs mostly pure hydrogen, or whether its accretion disk is rich in heavy elements left over from the first supernovae. Every answer generates new questions. TON 618 is not just an extreme object. It is a mirror reflecting all the imperfections of our current knowledge about space. And it is precisely these debates that move science forward, forcing us to build increasingly powerful telescopes to look even deeper into the darkness. Today, we are on the verge of a real revolution in astronomy. Despite the fact that TON 618 is located at a distance of 10,800,000,000 light-years from us, humanity is developing tools that will allow us to look directly into its kitchen. We are no longer satisfied with just random snapshots or general spectra. Our goal is to understand the dynamics of this titan and find thousands of objects similar to it that hide in the depths of the early universe. The James Webb Space Telescope, breaking through the dust. The main player in this game right now is the James Webb Space Telescope, a joint project of the National Aeronautics and Space Administration, the European Space Agency, and the Canadian Space Agency. Its ability to work in the infrared range is critical for studying objects like TON 618. Due to the expansion of the universe, light from distant quasars undergoes a strong redshift. When this light reaches us, it shifts from the visible range to the infrared. James Webb allows us to see not just a bright dot, but the detailed structure of the host galaxy in which TON 618 resides. This will help scientists understand how an ultra-massive black hole interacts with its environment, whether it promotes the formation of new stars, or, on the contrary, sterilizes the entire galaxy with its lethal radiation. The Laser Interferometer Space Antenna Project. Listening to the gravitational echo. However, light is only part of the story. The most ambitious step of the next decade will be the Laser Interferometer Space Antenna mission. It will be the first space detector of gravitational waves in the world. Unlike ground-based detectors that register the collisions of stellar mass black holes, the Laser Interferometer Space Antenna will be able to record low-frequency space-time fluctuations caused by the merger of true giants. When two black holes with masses of millions or billions of solar masses collide, they create a gravitational tsunami that passes through the entire universe. For TON 618, this opens up incredible prospects. We will be able to trace its family tree. If TON 618 grew through a series of mergers with other large black holes, the Laser Interferometer Space Antenna will allow us to hear these events, even if they happened billions of years ago. This will provide a direct answer to the question: is it the result of a gradual accumulation of mass, or the product of catastrophic cosmic collisions? Athena. X-ray anatomy of the hot universe. Another crucial tool of the future is the Advanced Telescope for High-Energy Astrophysics Observatory, which is being developed by the European Space Agency. It will be the most powerful X-ray telescope in history. X-ray radiation is the signature of the hottest and most energetic processes. It is exactly in X-rays that we can see the inner edges of the accretion disk located directly near the event horizon of TON 618. Athena will allow us to measure the rotation speed of the black hole, the so-called spin. This is a critical parameter. If TON 618 rotates very fast, it means that it absorbed matter from clearly ordered streams. If not, its growth was chaotic. The extremely large telescope and ground support. We do not forget about the Earth either. In the Atacama Desert in Chile, the extremely large telescope is currently being built with a mirror diameter of 39 meters. This giant will have such a gathering capacity that it will be able to conduct spectroscopy with incredible precision. With the help of this telescope, astronomers plan to conduct refined reverberation mapping of TON 618. This will allow confirming or clarifying the figure of 66 billion solar masses. In science, every number must be verified by several independent methods, and the extremely large telescope will become the main judge in this matter. Why is this important for us? It might seem that spending billions of dollars on studying an object that is so far away is a waste. However, scientists from the National Aeronautics and Space Administration emphasize TON 618 is the extreme point of testing our knowledge of physics. Understanding how such giants work allows us to better understand gravity, the nature of space-time, and the evolution of the entire universe. Technologies that are being developed for these telescopes From ultra-sensitive sensors to systems for transmitting data over vast distances, eventually find application in medicine, communications, and everyday life. We are preparing to tear the veil of the unknown from TON 618. The next 20 years promise to become the golden age of cosmology, where the darkest places of the universe will finally speak to us in the language of precise data. We have come a long way across billions of light years to be here, at the very edge of the knowable universe, at the threshold of TON 618. This object is not just a record in astronomers' catalogs. It is a symbol of how massive and at the same time mysterious nature is. When we look at 66 billion solar masses concentrated in the darkest point of space, we are forced to rethink not only the laws of physics, but also our own place in this grandiose cosmic performance. The era of black holes. A look into the future. What will be the finale for such a giant as TON 618? If modern cosmological models, supported by data from the National Aeronautics and Space Administration, are correct, then our universe faces a very long and very dark future. In trillions of years, all stars will exhaust their fuel. Galaxies will fade away, turning into graveyaries of white dwarfs, neutron stars, and black holes. In an era that scientists call the black hole era, objects like TON 618 will become the sole masters of space. Over an incredibly long time, numbers that are hard even to write down in words, for example, A1 with 100 zeros of years, they will slowly evaporate through Hawking radiation. TON 618, thanks to its colossal mass, will be one of the last objects to disappear in the universe. It will outlive humanity, the Earth, the Sun, and even the very memory of light. This is the ultimate victory of gravity over matter, a moment when time practically loses its meaning. Philosophical significance. Humanity before the abyss. Observing TON 618, we feel what philosophers call cosmic horror or the sublime. The scale of this object so surpasses any human experience that it seems almost unreal to us. Its event horizon alone could accommodate our entire history, all our wars, achievements, and dreams tens of thousands of times over. However, it is exactly here that the main triumph of the human spirit lies. We, biological creatures living on a small rocky planet near an ordinary star, were able not only to discover TON 618, but also to unravel its nature. Using only mathematics, logic, and our curiosity, we weighed this object, measured its temperature, and understood the processes occurring in its heart. TON 618 is the darkest place, but the light of our minds allows us to see even where photons do not penetrate, discoveries that change everything. The study of TON 618 proves to us that the universe is not obliged to be simple or understandable. It is full of anomalies that challenge our intuition. What we considered impossible just 50 years ago is today a proven scientific fact. This reminds us that science is not a collection of final answers, but a constant journey into the unknown. Every new article in the journal Nature or Science dedicated to ultra-massive black holes is another brick in the foundation of our understanding of reality. We learned that black holes are not just destroyers. They are regulators of galaxy growth, creators of the large-scale structure of the cosmos. Without such monsters as TON 618, the universe would be a completely different place, and perhaps there would be no place for us in it. TON 618 remains a beacon on the edge of darkness. It reminds us of the grandeur of nature and the infinite possibilities for exploration. As we conclude our journey to this titan, we do so with a deep sense of respect for the mysteries that are still waiting to be revealed. Perhaps out there, beyond the event horizon, lie the answers to questions about the origin of time and space itself. And although we will never be able to cross this boundary and return, we will never stop looking up, trying to understand the incomprehensible. TON 618 is not just a black hole. It is the limit of our imagination and a challenge to our science. We have seen how the darkest place in the universe becomes the source of the brightest knowledge. If this journey to the heart of darkness has made you think about the grandeur of the cosmos, then we have achieved our goal. Subscribe to the channel so as not to miss new explorations of the most amazing corners of our universe. Thank you for being with us on this journey through space and time. Until next time among the stars.